And let me introduce you Kat Jenny from the United Kingdom. Kat will tell us about structuring Go apps. She's writing in Go and PHP. Her main interest includes automating all the things, making things faster and simpler, sorting out legacy code. Kat loves traveling, keeping active, appreciates good coffee, and a huge Lego fan.
Good memory.
Kat also cycled more than 1,000 kilometers and raised more than $4,000 to support literacy and girls' education in developing countries. And I think that deserves a round of applause. So, Kat, here you are. Welcome. So let's start.
Thank you. Let's just test the mic. Does it work? Good. Okay. So a quick show of hands. How many of you have asked yourself this question at least once in your life? Right? Yeah. The rest of you are lying, I bet. So I think it's a question that all people new to Go are very likely to ask very quickly after they start their adventure with Go. But I think even if you've been doing Go for a while, even as an experienced developer, you still find yourself coming back to this question every now and then. It's certainly a question I ask myself a lot of the times. I've been doing Go for about 2 years, so I'm still fairly unsure about some things. And the idea for this talk came to me when I started thinking a bit more consciously about the way I structure my code. So there were a lot of questions I had and a lot of decisions that I felt like I had to make right at the start. Should I put everything in one package? Should I start with one package and then extract things over time, so like trust that organic growth over time? How do I decide if something should become its own package? Should I just use a framework and be done with it? And what's the programming paradigm for Go? Like, is there an idiomatic way of structuring my apps? Should I go for microservices? Should I stick with the monolith? And how much is it okay to share between packages? What should be shared, what shouldn't? So I'm sure a lot of you had these or similar questions. And application structure is not really something discussed very often. There is some information online, but not an awful lot, because most of the discussions tend to focus on design patterns, rather than the where your files go on disk dilemma. And then everybody has their own favorite ways of doing things, their own preferences, their own best practices. And Go as a language doesn't really give you many hints. It kind of leaves it up to you, which is great because you can experiment, you can have fun, you can tailor it exactly to your needs. But it also means it can be hard to get started without any pointers whatsoever, especially for people who don't come from a C background, or people who come from the more traditional object-oriented languages like Java, and they come into Go and they expect to see classes and objects. Why is this important? Like, why should we care about structure, right? At the end of the day, it's just where my files go on disk. Who cares? Well, Dave Cheney said in his Golang UK keynote that if Go is to be the language that companies invest in for the long run, the maintenance of Go programs and the ease of which they can change will be a key factor in their decision to pick Go for their next project. And I think that's very true, because without a good strategy right at the start of your project, you'll just find your code getting more and more messy over time, and you'll find your code scattered around random packages in random ways over time. And typically, once you make a major architectural decision, you're kind of stuck with it. It's then really hard to shift gears later on and suddenly refactor everything to be done in a completely new way. So that's why I think it's important to consider it and try and get it right-ish. Not right, but right-ish from the start. So what's a good structure? Well, let's define that first. Ideally, it should be consistent across the project. There is nothing worse than coming into a project and seeing one part of the project done in one way and then another part done in a different way, and then you have no idea which one to follow, especially if you're not the original author of that project. It should be easy to understand, easy to navigate, easy to reason about, so it should just make sense to you. It should be easy to change, loosely coupled. It should be easy to test. It shouldn't hinder testing in any way. I really love this quote. This is attributed to Einstein. It should be as simple as possible, but no simpler. And I really love it because it really captures the Go way of thinking really, really well. Because it basically says, keep it as simple as you can, but not simplistic, which is the hard part. And then the design of your code should reflect exactly how the software works. And then the structure of your code should ideally reflect that design that you picked exactly. So if you apply the transitive law to this, then the structure should reflect exactly how the software works. And you might think, that's obvious, but how many times have you come into a project where the structure suggests that it works in one way, but actually it turns out that it does something completely different, and it seems like at some point the structure just stopped following how the program is designed to work. And I really kind of want to make this point because it's ultimately the holy grail of good code structure. You know, your design could be anything. You could use any of the paradigms. It could be functional, it could be object-oriented, it could be procedural, it could be concurrent, it could be not. It doesn't matter. Whatever you picked, you want your structure to reflect that design. And again, why is this so important? Well, ultimately, your code is your only most up-to-date documentation of the business logic that you have, of the vocabulary that you use, of the terminology. So a good code structure which isn't diverged from that design and from your business logic, it's key to and critical to make your code understandable and maintainable and kind of self-documenting. So I guess the TLDR of this is that good code structure should make your life easier as a programmer. It should work for you, it shouldn't work against you. And it should make coding a pleasure because you should know exactly where everything goes and where you should add anything new that you want to add. So that's all great. Well, how do you get to that point? Well, the sad news is that it kind of comes with practice. There is no definite list of instructions that I can give you to say, if you follow those 5 things, you magically arrive at the great structure. So instead, I thought I'll try and show you a few different ways in which you could implement the same app. And I didn't want to use an example with foos and bars because that's not really what real life is like. So I went for beers and bars instead because beers and bars is what life is all about. So imagine I gave you this spec for a simple beer service. So I want a user to be able to add a beer, and I want a user to be able to add a review for a beer, and I want the user to be able to list all the beers and list all the reviews that we have. And for simplicity, we'll skip updating, deleting, and so on and so forth. So it's not a full-blown production-ready API. It's just a fairly simple example. And I also want this application to give me an option to store data either in memory or in JSON files. So in real life, it could be a SQL store or a NoSQL store. And I also want the app to give me the ability to add some sample data, so to pre-populate the database with some sample beers and some sample reviews. All right, so now that we have a spec, let's look at how we could implement this. Well, let's start with the most obvious structure, which is a flat structure. So we could have the following files. So we could have data for the sample data, handlers for the HTTP handlers, main for starting everything up and tying it all together, model for defining our beer and review structs, then storage for defining the functionality that we expect from the storage, and then a file for each of the storage types. So immediately, you can probably think that this structure is easy to navigate, especially if you don't have too many files, right? It's a good starting point when you don't know where to start with your project. I think the flat structure is what you should default to avoid the analysis paralysis and trying to overcomplicate things before you even wrote a single line of code. Flat structure works really well for small apps and small libraries, I would say maybe 10, 20 business operations. And it goes well with the idiomatic approach, right? It keeps it simple. And one great benefit of the flat structure is that it removes any chance of circular dependencies because everything is in the main package, so you'll just never run into this problem. But that also points at some disadvantages with this. One of them being that everything is in a global state, so you have no way to black box anything or make anything private. Secondly, looking at the structure, can you tell me what this app does without opening a file, right? Not really. The file names don't really give you much of a clue. I mean, you can probably tell that it's maybe an API that stores something, but that's about it. And this might get hard to organize and navigate if it grows over time. Like if you have 100 files in one directory, it might be a bit tricky to start navigating this. So usually for this talk, I sometimes sort of bring the code into the talk, but like because we've only got 40 minutes here, or 35. I will share a link to a demo repository where this is all implemented, so you can go through it in your own time and see how it's actually done. So in the demo repository, there is a directory called flat, where all of this is implemented, so you can run it, see how it works. So let's see if we can break this up somehow into smaller packages. Well, there are, of course, a few different ways that you can go about breaking this up. So let's start first, try grouping the code by the function that it performs in your program. So this is formally called as the layered architecture. If you imagine your application having different layers, so you have the UI layer or the presentation layer, and it will have the business logic layer with all your models and all your actions, and then at the bottom it will have all the third-party dependencies, anything external, databases, and so on and so forth. So you can group the code based on which layer it belongs to. So if I said things to you like controllers, views, models, actions, well, that all sounds like an awful lot like a classic MVC, and that's exactly what it is. So MVC is used, model view controller, so that's what MVC is. It's used by a lot of frameworks, and the main reason is it's a fairly generic way to break up almost any app. So it fits the generic case really well. So in our case, we could have something like this. So I've added packages for the handlers, for the models, and the storage. So the good thing about this structure is that it's fairly easy to decide what goes where, at least up until a certain point. It discourages you to use the global state and start thinking about maybe separating or blackboxing some of the things. It could, however, be problematic, because if you have a variable or something that needs to be shared by two layers, then how do you decide which layer does it go in? So you start running into those little dilemmas. And then where do you initialize everything? Like, do you initialize the storage in main and then pass it into every model, or do you kind of leave it up to every model to initialize its own storage? So those little decisions as well that you have to make. And naming is kind of difficult again, because we've got a models package, but we also have a storage, not storages package. So if you've got a slight OCD, and it might start annoying you over time if you you might end up being inconsistent over time, because some things will be plural, some things will be singular. And then each one, in this case, you tend to have usually one file for a model, and that can get very large over time, and over time it can start containing a lot of unrelated things. It's just because it's about a beer, it will end up in the beers file, but actually it might be fairly unrelated, and those files can get really big really quickly. And also, having just one definition of a beer, it doesn't let us apply different contexts to it, so we always have to use the same beer structure, no matter whether we're adding the beer or listing. And where that becomes awkward for somebody trying to expand or code something into this API is that normally the beer structure is going to have an ID field, because a beer has an ID. So when you're listing a beer, you want that beer struct to come back with the ID. But then when you're adding a beer, you don't know whether you should specify that ID or not, because your intuition is probably, well, the app is going to generate an ID for me and save it in a database. But when you're looking at the struct, it has an ID field. So at this point as a user, you don't really know. It's not very intuitive how you use this code. And the biggest problem with this is that actually this program won't compile. If you try to run it in the demo app, it won't compile because of circular dependencies. And that's very common when you have the middle layer, so the models being used by both the top layer and the bottom layer. It's very easy to run into circular dependencies. And in our case, we've got the models, which use the storage functions to save the beers and list them. And storage depends on the models to actually define the beers and reviews. So the circular dependencies between models and storage. So this actually won't compile. So let's try a slightly different approach. Let's try to break it up into modules. So for example, by modules, I mean things like beers, reviews, storage. So basically, everything to do with beers goes in one package, everything to do with reviews goes in another package, and so on and so forth. So at least in this case, things are somewhat grouped logically, like beers there, reviews there. But that's probably the only advantage you get with this approach. It's kind of hard to decide where the barrier, where the sort of limits of one package are, because do reviews, should they be in their own package or should they be in the beers package because they are beer reviews? So they're like a sub-package of beer. Naming is worse because you've got beers.beer now. So you've got stutter, not ideal. And this also still won't compile because you've got the exact same circular dependency, just slightly moved around. So let's try a different way. Let's try grouping by context. What do I mean by context? So this way of thinking about your application is known as domain-driven design. Who heard about DDD? Show of hands. Oh yeah, cool, half a room. Great. So it's an approach to software development which was popularized by von Vernon in the classic big red DDD book. It might seem fairly complicated and academic at first when you start reading it, and it's a really thick book. But it's actually quite a natural way to think about your apps once it clicks in your head, and it just might take a while. DDD is not at all where your files go on disk. It has nothing to do with actual structure, but it can help guide you and help you find the right structure really well. So what's DDD and how does it work? Well, first of all, it makes you think about the domain you're dealing with and the business logic in your app before you even write a single line of code. You define your bounded context, or contexts, the models within each context, and the ubiquitous language. And all these terms are DDD terms, so they're like very formal terms. What's a bounded context? Well, essentially, it's a limit around a particular model in your app. So it's a boundary around that model, and you can have many of them in your apps. So to give you an example, if you think about a user as an entity, if you take the context of somebody working in the sales department, a user might have attributes like the lead time or the cost of acquisition. But if you spoke to somebody from the support department, they probably won't care about the cost of acquisition of the user, but they will probably care about things like the average response time or the number of tickets submitted. So those are the two different contexts. We've got one entity, the user, but we've got two different contexts in which we can reason about this entity. And the context essentially let you define what needs to stay consistent in a particular context around a particular entity and what can change independently. So if you wanted to add another attribute to the sales context, it should be fairly easy to do without sort of disturbing the support context. And then you start identifying the building blocks of your system. So you're starting to see in your app what's a value object, what's an aggregate, what's a repository. And these are all sound really formal, and I'm not going to go into the definitions of each of them because it takes a while to wrap your head around them. But instead I'll try and explain them based on what we have in our demo app. So in our demo app, we kind of only have one context here, and that's like a beer tasting context, right? We have somebody, a beer connoisseur, drinking a beer and wanting to write a review for it. So that person probably will care about things like the alcohol percentage, the ABV, or the flavor notes of a beer. They probably won't care so much about a barcode on a beer. But if we had a different context, if we had a beer manufacturer in our application as well, they probably very much would care about the barcode, probably not so much about the flavoring notes. So let's just assume for simplicity we only have one context here. The language we're going to use throughout is beer, review, and storage. And you might think that's just a complete waste of time, and that's obvious. But how many times projects end up being inconsistent down the line because somebody is going to start using a slightly different word to name the same thing, and then somebody else is going to use a different word again. So instead of just using storage, you're going to have database, repository, storage, and probably a million other things when you all mean the same thing. And it can just be very confusing. Whoops. There we go. So you might think it's a waste of time, but actually it really saves you a lot of inconsistencies down the line. And it's also really nice to agree with not just your developers, but everybody, all the stakeholders in your business about the language that you're going to use to try and agree on how something should work. Because you're all going to use the same language, and therefore you're all going to understand each other better when you're talking about how something should work. UK, US spelling is another common one that is really good to agree on very early on. The differences, or if you're developing in a foreign language, then like, do you use English names, do you use your normal names? It's good to agree on that early on. So that's what the ubiquitous language is there for. The entities we're going to have in our app are beers and reviews, and the value objects objects could be something like a brewery or a review author. And you might be wondering what the difference is between an entity and a value object. And the difference is if you think about an entity, it's basically an abstract concept that you can have an instance of. So it's a single identifiable item in your app. So things like a customer, a user, a blog post, a beer, those are all entities. So, and you can have an instance of an entity in your app. Value objects are just a slightly smaller concept. It's similar to entities, but value objects are not really entities on their own. They can be a part of an entity though. So they're a bit more like properties to entities. So for example, a barcode value object is not really an entity on its own, but it's part of the beer entity. And then on top of that, you can have something called aggregates. And aggregates combine the entities together. So if you have two entities that are linked, for example, by an ID, then you need an aggregate to create that meta-entity object, essentially. So in our case, the beers and reviews are linked by the beer ID. And so we would technically need something called an aggregate to create us this beer review meta-entity. Services are stateless operations in your application that sort of go beyond the responsibility of a single entity. So the services is operations in your system that the entities shouldn't be performing by themselves. So in our case, we have beer adding, beer listing, and so on and so forth. Events, it's what it says on the tin. It's something that can happen in your app that can change the state of the application and influence the domain. So in our case, we can have things like beer was added, beer was not found, and so on and so forth. So it's anything that can happen in your app that can affect the state. And finally, we have repositories, and they're essentially facades over a backing store. So in our case, we have a beer repository and a review repository, and we could be talking about the same database, or we could be talking about two separate databases. We don't care at this point. So DDD is all about defining your domain in abstract terms, not really caring about a particular implementation or whether this will be one database or different ones. We don't care. In abstract terms, we have two repositories because we have somewhere to store beers and somewhere to store reviews. So this may not be 100% correct because it's all very subjective. So if I gave you the same spec and asked you to come up with this, we probably would have come up with slightly different ways of breaking this down. And it's essentially something that you should agree on with your team. DDD just helps you to understand what you're dealing with in your system. It helps you reason about your design. And as you can see, you can apply it to a problem of any size. You can just leave some things out for smaller apps. So in this case, it's probably a little bit of an overkill. And if you look at the demo repository, I actually didn't bother implementing the repositories or the aggregates in my app because the entities are so simple. It was really an overkill to try and squeeze that in as well. So what I would say is don't be afraid to leave stuff out of DDD if you just don't have it in your system. It doesn't mean that every single application is going to have all of those elements. They probably won't. So a first take on this, we could have the following. The first change is that now our package names communicate what they provide as opposed to what they contain. And each package has just one purpose. So we've got adding, listing, and reviewing. It's easier to avoid circular dependencies this way because now the service packages, so adding, listing, and reviewing, they talk to the storage package, and the beers and reviews models are kind of like entities are kind of left out. So we've broken that circular dependency there, which is really nice. So this actually will compile. But there are still some slight problems with this. For example, how do I add sample data? So far, in all the implementation, the sample data was added in the init function. So every time you run the app, it will go through the init function and try and add sample data. Well, that's not ideal because I don't have any control over when I add the sample data. It just happens every time. So if I wanted to somehow extract this from the main, then how would I do this? Like, I can't put a second main.go in here. And what if I just wanted to completely change the interface for this app? What if I wanted to have a command line interface instead of an HTTP API that would like prompt me to add a beer and add a review, right? How would I add this in the structure? So there is something that can help us with that, and that is the hexagonal architecture. In a nutshell, it's all about starting to distinguish in your app what forms the core domain and what's an external input or output in your application. So external inputs and outputs can be your external APIs that you talk to, your databases, any cloud services, any mail services, and so on and so forth. So what's sort of the main goal of the Hex architecture? Well, the Hex architecture is all about enabling you to make changes to one area of the application and keeping those changes local to that code. So the goal is essentially to be able to change a part of the application without having to change everything else. So for example, if you wanted to swap out a SQL database for a NoSQL database, the idea here would be to be able to make that transition really smoothly and without really affecting much of the business logic itself. And rightly so, because the business logic shouldn't really care about implementation details. It shouldn't really care how you store your data. So in the Hex model, both inputs and outputs, it doesn't really distinguish between them. It's just external interfaces. And they're sort of all on the same level as opposed to the top-level MVC view. How do you achieve the goal of being able to easily change one part of the app without affecting much else? Well, the key rule, and pretty much the only rule you have to remember from the Hex model, is your dependencies are only allowed to point inwards. So the core domain, the outer layers can reach into the core domain for the definitions of structs and the business logic as much as they want to, but the core domain itself cannot reach and reference anything outside of itself. And so that implies a heavy use of interfaces and inversion of control, and indeed, you're going to have to define an interface at every boundary between each layer that then the outer layer will need to satisfy. And so as long as the outer layer satisfies the interface that is defined by the inner layer, you can just swap that outer layer easily in and out without really having to change much else. So how would that work for our demo app? Well, we have kept the service packages. So the service packages are in yellow here, adding, listing, and reviewing. But we have pulled the definitions of the models or entities into the service packages now. So you'll notice that there is a beer.go here, and a beer.go here, and a beer.go here. And that allows us to define the same entity in the slightly different context within our app. Depending on whether you're adding or listing, you're going to have the ID or not. And also things like the JSON hints, like the JSON field names and the backticks that you usually define on the structs when you're JSON decoding, that can only be defined here now, because only the JSON implementation of storage actually cares about it. And so we solved that problem really nicely with being able to have slightly different definitions. So it's a bit more intuitive for somebody using those structs. And then the packages in blue, HTTP and storage, are just the input and output interfaces. So they provide storage implementations and the HTTP handler implementations. And you might have noticed as well the addition of the CMD CMD and PKG packages. And you might have seen the CMD in the open source projects online, and you might have been wondering, like, why are people adding this? What is this? And that's certainly what the first time I saw it, I was like, why? What's the point of doing that? Essentially, CMD is where you put your binaries in your application. So you separate the binaries from the rest of your code. And then if your project has a lot of non-Go files, you can put all the Go code in your packages inside a packages top-level directory, which is abbreviated PKG. So PKG stands for packages. And again, I want to stress here that if your project has a lot of non-Go files, you might consider putting that in. You don't have to put it in. If your app is fairly small and doesn't have much else other than Go code, you don't have to put it in. It's completely optional. All of it is completely optional. So it's a trend, but I think the CMD package especially is a bit of a standard these days. So the side benefit as well of separating your binaries, besides the fact that now I was able to separate the adding of sample data and the actual beer servers into their own binaries, so I can run them independently, another problem solved. A side benefit is that you now control the name of your runnable binary a bit better, because if you do go install or go build, it will end up having the name of the package that you give here. So that's like a nice side bonus of that. And what if I wanted to, coming back to the problem of what if I wanted to add a new client, like the command line interface? Well, it's as simple as just adding another subpackage under CMD, another main.go, which will start up the command line prompt. And that can still use all the services that are defined here. I don't need to change anything in the PKG package just to add a command line interface. So looking at the package names here as well and the file names, it kind of tells you what the app does. Like you've got adding, listing, reviewing, you've got beer. So you kind of get a good idea just from looking at the structure of what this app actually does. So the code is a bit more self-guiding. And then I already mentioned this, but it's really easy to extend the structure. For example, if you wanted to change this API to be a different flavor of HTTP, if you wanted to make it a SOAP API or an RPC API, it's as simple as just adding another sub-package here, defining your handlers in a slightly different way. And again, all of these can still use the domain packages, adding, reviewing, and listing, and they don't need to change again. So a quick note on, I was a bit undecided on where to put the sample data, and it just shows you that it's end of the day, it's just whatever you agree on with your team or with yourself, whatever works for you best. So I ended up adding them in the sample data directory here, and they're defined as Go slices of beers and reviews. My service files define, like the service in adding and reviewing, they define a function, a method to add sample data. So I could put them inside the adding and reviewing packages as well, because it's like sample data go next to the function that adds them. Or I could have a top-level resources directory and define those sample data in a non-Go format, so in a YAML file or in a JSON file. And then when I run my beer server here, the beer server could read those files in, parse them into the Go slices, and then pass that to be added. So probably if this was a production application, I would do something like this. I would define them just in a top-level resources directory. So I thought that gets you to a pretty good state with your app. Of course, this is probably overkill for simple apps. I still think flat structure works perfectly fine for this. And I just wanted to make a point here that you can apply the DDD thinking to a flat structure as well, because DDD is not about any particular structure. It's more about how you think about your apps, and you can just as easily do it in flat files. So at this point, you might be thinking, is there a framework that would just do all of this for me? Yes and no. Like I said before, most frameworks are MVC-based, so like Go Buffalo and probably a bunch of others mentioned here. I can't remember the name, Martini, I think. They are all MVC-based. A kind of nice in between is this Go build template project that I found, that it defines a make file for your Go app, and it starts out with the CMD and PKG directories, but they're all empty inside, so you can still implement the app however you want. It's just a nice shortcut to save you some boilerplate and like retyping the same thing for every project. I'm not against frameworks. I think they're really nice and they save you some time for sure. I still think it's worth starting out with a blank page and experimenting with those structures yourself, even just prototyping, to really get a good understanding of the benefits and downsides of each. And then that allows you to then recognize all the patterns in all the frameworks that you come across, and then you can judge the frameworks better. So I'm not against frameworks at all, but that's why I haven't spoken about them much, because I kind of prefer going about it the other way around. So like learn from first principles first, and then maybe jump into a framework. And then keep in mind that once you pick a framework, you kind of have to stick to the structure that the framework forces you to use. So there's not much you can do about it. A few words on testing before we wrap up. I think it makes sense to keep the test files next to the files that they test. I don't really see the point of replicating the whole package structure in your tests. I think it's perfectly fine to keep the tests close to the file that they test. And it's fine to use a shared mocks sub-package. Like mocks are mocks, they don't have any logic. There's no reason why they couldn't be reused in tests, so keep them in a shared mocks sub-package. We all know there's two hard things in computer science, naming, cache invalidation, and off-by-one errors. So a few words on naming, besides that it's hard. Choose package names that suggest well what you can expect inside. Avoid generic names like util and common and all of those, because they just end up being dumping ground for lots of unrelated stuff over time. Follow the usual Go conventions. Like there's a link to Andrew Gerard's talk it's a very short talk on the usual Go naming conventions. Avoid stutter, so things like strings.string reader, string reader. And think about accessibility. It's something I only become aware of after seeing an excellent talk by Julia at GopherCon. She's somebody who codes with the help of a screen reader. So choose names that will be read correctly by the screen reader, and they will make sense to somebody when they are read out loud. So A very quick word on the main function, and I'll pretty much just defer to Matt here. You'll probably find over time that if you apply the DDD thinking and start pushing logic out into your packages, your main just becomes really sweet and short, and it just really initializes everything together and ties it all in. You could have flag parsing or do some initialization here, but even that you can just push out to the run function. So you might find that over time your main just starts looking like something like this. So it has 2 lines in here, 4 lines in here. So let's quickly recap. Flat and simple is okay. There is nothing wrong with flat structure. Don't think that it's just like a sign of being a newbie or anything because it doesn't look complicated. Flat and simple is fine. The convention these days seems to have those 2 top-level directories, at least the CMD directory for your binaries and the PKG if you need it for all the rest of your Go code. Favor grouping by context instead of functionality, that, especially for large projects, that tends to work in your favor. Try DDD or Hex as well. You will probably find that dependencies or any implementations of external inputs and outputs, they almost always end up being their own package. Put the mocks in a shared subpackage. Keep all your other non-Go files in the root directory of your project. Keep your main sweet and short and make it tie everything together. And avoid global scope and the init function. Avoid global scope for better maintainability, so just to have less dependencies between your packages. And the init function, it was bad in my case. For example, like I mentioned, the sample data adding was initially implemented in the init function. Well, the problem with that was when I was writing my tests and I was running my tests also run the init function. So every time I was running my test, I was trying to add sample data. You can't control init, you can't turn it off, so probably just avoid using it. So I'm sorry I don't have a single recipe for success for you here. I hope I managed to clarify the different approaches a little bit, though. There's no single right answer to code structure. It's literally whatever works for you and whatever works for your project. Even my examples, it's just an example approach. They probably could be improved in some ways. So if you have any suggestions, by all means, send me pull requests. Be like water, like Bruce Lee said. So almost expect the structure to change over time. You should expect that your domain and your language will morph and be expanded over time. So you should almost not expect to get the structure right from the first time. It's very likely that it will have to evolve over time. So be prepared to change, be prepared to adapt over time. Don't overcomplicate for no reason. Go for the simplest solution for today, don't code for the future. Above all, be consistent in your approach. It will help you, your fellow colleagues will appreciate that as well. Prototype, experiment, have fun with it. Prototyping really helps you ask the questions you didn't even know you should be asking. And remember that good choices and best practices, they really come from experience and over time. And we've seen that in the community. We didn't start out with the CMD packages. It was just because a few people posted about it and then it just picked up and it was refined by the community over time. So have fun experimenting and share your ideas so that we can all benefit as a community. And if it wasn't for people who shared their thoughts so far, we wouldn't have all the best practices that we have today. So speaking of those people, a huge thanks to Peter Bergen, Ben Johnson, and Marcus Olsen, and many others, because they shared a lot of their thoughts on code structure online. So I encourage you to read their, I will tweet out the link to the slides so you can go and have a read. And just to wrap up, a few more links from me. There is an article on Go and package-focused design on the Go for Academy blog. Brian Ketelsen gave a very complimentary talk to mine at GopherCon Russia earlier this year, so that's a really good one to watch. If you want to read more about the hexagonal architecture, then Chris's post is excellent. And then finally, the demo repository is on my GitHub, so you can go and have a look at that. And my Twitter is at the top, so if you have any comments or questions or feedback, then by all means, tweet me. And I think the tweet with all the slides and all the links has just gone out or is about to go out, so I will also post it on the Telegram for those of you who don't have Twitter. So with that, thanks for listening so much, and I hope you enjoyed the rest of the conference. If you have any questions, I don't know if we probably don't have time for questions, so I will hang around and I will be at the social later on, so you can just feel free to just grab me and ask me questions then.
Okay, thank you, Kat. I think we'll have some time for questions.
I think we've got 2 minutes, yeah.
Yeah, like 4 minutes, I think.
Yeah. I try to leave like 5
So
minutes.
please raise your hand.
So I have a question about utils packages. For example, there are utils package like string util or AST util, type util that are in the standard library in the X packages. So it's a problem with Go if we have many small packages like left pad in JS. It becomes a different problem when we have separate dependencies.
So
And
what you're talking about is slightly different because you said yourself standard library. Libraries are slightly different to apps.
I mean, there is something outside standard library that can extend some packages, like utilities on the AST or type information. And if you separate this by function or by any other feature, it becomes separate dependencies. So the user have to have many dependencies instead of one. And usually those packages are called like X-util.
Yeah. So like I said, with libraries it's a little bit different because libraries is something that you sort of plug into your own application. Like, so my talk was more about the application structure, not library structure. And then I think if you define your context really well, you'll find that like you shouldn't really have anything or very much at all shared between the different contexts. So you'll naturally, I think you should find that there is nothing to share. So there is just no need for the utils package. Usually utils, if you think about utils, you should ask a question of what is this thing that I'm about to put in the utils package and what's a better name for it to like suggest to somebody what it actually provides. Because utils just ends up being a dumping ground for a lot of just random things.
Yeah, but it solves the problem with multiple dependencies. I think this is the only reason why some packages are united together.
I think I'll have to see an example of what you mean because I'm not sure about what you mean by the...
I can show you.
Yeah, let's talk about it later, yeah. Anyone else?
Any more questions? Probably one question for now, and we'll continue to another speaker.
Oh.
Okay, thank you, Kate, for your talk. It's a great, amazing, because in our project we almost have the same experience. In a year, we moved from the model structure to the domain DDD, yeah, the things. My question was maybe in several things, maybe about layered architecture and hexagonal architecture. What's the difference between them?
So the main like, obvious difference is that layered sees things from top to bottom. So you see like inputs, domain logic, and outputs for the external ones. Hexagonal sees everything as just an external dependency. So it doesn't tend to differentiate between the input and output. It's just external dependencies. That's like just looking at the models. Like the layered just tends to like put the focus on the layers and kind of the order in which they are executed. The hex domain doesn't really care about it. Other than that, it's kind of very similar, except for the layered architecture. You have your business logic like spread between the layers, right? Because your controllers and your models will be part of the, like controllers could have some part of the business logic as well as the purely the HTTP handling, whereas Hex is very clear about everything to do with the logic goes inside and everything external goes outside. So I think layered architecture still lets you sort of mix the context a little bit, like spread the business logic between layers, whereas Hex is like all the business logic is one layer. And like it's not really a layer, it's like the circle inside.
Yeah, do you have some small time for second part of the question?
I'll chat to you outside if you want.
Okay.
If we're out of time, then yeah.
Okay, thank you for your questions. And Kat, we have the contest of presenting a shirt for the best question, though we had only 2. Maybe you can decide whom it will go.
Do you want a second t-shirt? Ivan's going to want a second t-shirt, yeah. Give it to Ivan.
Okay. Okay, so let's thank once again Kat for an interesting talk.